This object square rooted then equals 3x, so let's differentiate then. Gives. So this square root is power half, so it's something to the power half. You can put a wrapper bracket around it and it's all that to the power half really. So let's differentiate that. There's a half up here, half in our mind's eye, it's power rule, so we half of the something to the minus a half multiplied by the something differentiated, so we'll need a bracket, and it's u times the v dx, which is, this is v, so that differentiates to 3, plus v times du dx, which is minus 2y dashed, isn't it? So that was this object, half of this to the minus a half, multiplied by the something differentiated, which was a product. And we used the product rule, u to v dx, which were these two, plus v times du dx, and that differentiated to minus 2y dashed. All of that equals this differentiated, which is 3. So here we're going to have to put this term in here, 1 minus 2y, 1 plus 3x. Now, if we move this 2 from divide up to times, we'll get 6. And then this minus a half is like a power half underneath on this side, can move up to a half on the other side. But we know the half on the other side is already can be replaced by 3x, so I can just simply write that as 3x without having to write it. And then on left on this side, the left hand side, is this stuff here which I'm going to expand. So we've got 3 minus 6y for these two terms, from 3 of those and 3 of those, plus, but there's a minus here, isn't there? So I'll have to be careful. It's minus 2y times 1, y dash that is, and then minus times plus is minus 6x y dashed. Okay, so we now know. Let's just take the y dashed outside. Let's move these two terms over to be with this term. So we've got 18x plus 6y minus the 3, and that's equal to y dashed, bracket, and then we've got a minus here, so I'll put a minus there for now, and there's going to be 2 plus 6x. We can take a 2 common out of there, can't we? So we need to tidy up a bit more. So that tells us then that y dashed is equal to. Now I'm going to flip this around because I'm taking that minus over there through all these three terms here. So it'll be 3 minus 18x minus 6y. So all of them were times by minus because I took the minus over effectively. And then here I'm going to take a 2 out and write 3x plus 1 in that way. So that's my 6, that's our 6x plus 2, isn't it? And the y dash gets left there. So that looks like here. So let's just check. I'm just going to do a tiny check through here, just to be sure I'm okay. Something to the half differentiates to half something to the minus half multiplied by the something differentiated. It's a product, so it's u to v dx plus v du dx, that differentiated to minus 2y dashed. And that's equal to this differentiated, which is 3. This was minus a half, so you can think of it as underneath the power half. Move it up to the other side from times to divide, from divide essentially to up to times, and you can replace it by 3x. But there's also a 2 coming up, so that gives you the 6 and the 3x there. Here now, here we've got, expand this bracket, we've got 3 minus 6y minus 2y dashed minus 6xy dashed. So that's good. And then let's have a little look at that then from here on in. So we're okay with this line now. This is 18x plus 6y minus 3 moved over. The y dash can be taken outside with the minus. 2 plus 6x. Now we can move that from times to divide. Take a 2 out as common. And the minus we can run through here. Move that minus from times to divide. Or times both sides by minus 1. Minus 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 makes that a plus. So we'll write it that way round. And then this 2 comes out and we get 1 plus 3x, which we can write as 3x plus 1.